All right, so we want to calculate the pH of this. Now, you can kind of see it there. It's like 0.1 molar. Right there, you see it's 0.1 molar. And I know that the pH reading meter is saying 2.9, but I want to do this like from a textbook perspective. We're going to, acetic acid is a weak acid, and with weak and strong acid, weak acids, you got to use rice tables or ice tables to calculate them. So in the lab, you would just measure the pH, but on the exam, you're going to need to know how to do this. All right. I made a little flow table or like diagram. I'm like obsessed with these things. Anyways, so you want to know your pH or your pOH of a solution. This is for weak, and now you're given a bunch of things. You're going to be given the molarity. All right. You're going to be given your Ka or your Kb, your acid ionization constant or your base ionization constant, or you might be given your pKb or pKa values. All right. Now, this is for acids and bases. Now, there's two separate ways to do this. For a strong acid or a weak acid, you're going to do two different things. For a strong acid, you're going to use your molarity for your concentration of your respective H3O plus if it's an acid and hydronium if it's a base, or OH if it's a base. Whereas a weak acid, you're going to use your rice table. All right, and that's what we're going to practice today. Before I actually do this, I want to go over a couple things about it. These are the formulas you're going to use from your reference sheet. You can see there's 5 of them. And these problems, they feel to me like a huge tide boot where you have to do one knot and then you get another knot and then you get another knot. So I want to go over a little formula tree for you, all right, to help. I hope just when you go back to do them or go back to study them, it'll be a little more clear as what you need to do. So for either of them, and I would set up like a big sheet of paper where you have a lot. You got to start with your equation. Make sure you know what the equation is. All right. If it helps for you, label the acids and the bases. All right. They may tell you, but I think the equation is a good place to start. Now, for an acid, you may know your molarity or your pKa. All right. And if you know your molarity and your Ka, you can go straight to your rice table. If you're given a pKa, remember that's the log of the pKa. So you have to use pKa is the negative equals the negative log of your Ka. All right, and transfer this to that. Once then, and I would circle the steps. All right, the things you need. These are the formulas. You can write them down if you want. Once you know your Ka value, you need to make a rice table, and you're going to use your ionization constant expression. These two things, you use your rice table to figure out what you're going to do, and that's going to arrive you at a hydroxide concentration. Then you're going to use pH is equal to negative log hydroxide to go to pH. Boom, done. All right. Now for base, start with the equation again. Bases are a little bit trickier because sometimes in our acid system or the acid, I feel kind of weird saying that, the acid way that the pH is set up, you're given a pKa of its conjugate acid for a base. And you don't want that for a base. All right. If you're given a pKa, you can get to the Ka because Ka plus or pKa is equal to the negative log of the Ka. All right. So you use that equation to get to your Ka. Ultimately, you want to get to your Kb for your acid. You could go from your pKa of your constant, your pKb with pKa plus pKb equals 14. All right. And then go from your pKb to your Kb with pKb equals the negative log of your Kb. All right. That's a log. All right. And then you could also go from your Ka to your Kb with Ka times Kb equals 1e to the negative 14th. All right, so you have some options there. Now you'll notice these formulas are all on this thing, all right? If I'm sorry, there's my pKa, I get my Ka, then I jump to this to get to my Kb, all right? Or I start with my pKa, go to my pKb, get my Kb, all right? So you have options, all right? And they're all here, and it's up to you which one you want to use. All right. Now, once I have got my Kb, my base ionization constant, what I do then is for a weak base, I'm going to set up my Rice table, all right? And I'm going to set up my equilibrium expression and substitute my values from my Rice table into my equilibrium equation. And that's going to arrive me at a concentration of hydroxide, all right? Sometimes they'll want to know the pH because that's typically how things are measured. They don't measure pOH. We measure concentrations of pH. Well, you have some options here, all right? You could go to hydronium, and that's going to allow you to use your Kw equals that equation, your Kw equation, all right? And once you get there, when you have a concentrate, you would use this formula. The original pH formula, you take the negative log of it. If you want to, you could also go get your pOH. Your negative log of your OH concentration. And once you have your pOH, you can get to your pH from pH plus pOH equals 14. All right? So that's the formula tree for weak acid and weak base. Now I'll use it for some examples in the films below. All right? I hope it's helpful. Bye.